So thanks, students. A little bit of a delayed start because of glitches in technology, etc. But yeah, so yesterday we did this lecture 1. I want you to go back to that and refer to it so that you can answer this lab 1, which I'm not going to go through it. With basically what it is it gives the names of all of these important people for us from the historical point of view of computing, and then you're to try and put them in order from first to last in terms of time. So you'd remember the first thing that we saw was this abacus thing, right? And from there on down to the more later ones. So that's an exercise for you to do. I've left that PowerPoint there for you because you really need to refer to it in order to answer that. So what I'm going to do now, I think I'm going to get my snip going because I'll make a note of who's here. It's kind of hard to just write down all the names and that, but I can see in the participant list who's here. Nobody's here at the college, so I guess that maybe that is a factor of the fact that it's 7:30 a.m. I mean, I do have the door open. You guys are always welcome to come to the class, but I see that you prefer to do online. That's fine. So here we are with this. You guys okay with this? I'm going to try and make this take up my screen. That away. Computing today. I hope this is big enough for you in the thing there. So basically, the idea of this part of the lesson. Can you still see this? Can somebody comment to me? Can you see this? Or maybe
yes.
Yeah. Okay. So you can see all these screens and stuff. Can you see that?
Just there is a Zoom announcement. Just can you remove it?
Zoom announcement.
The meeting is being more like a notification. It says the Zoom meeting is being recorded. Just
yeah. Well, sorry, I can't see it. It's on your screen, not mine.
Yeah.
You can click on got it only.
Yeah, I did it.
Okay.
Okay.
All right. So
Okay.
the computer there, what you're looking at here, this is kind of like our Mac things, but I don't know if that's Mac or not. PowerBook, but Power, whatever they call them. And so this is a desktop computer, I suppose, a laptop. These are really quite powerful machines nowadays, and we've got a lot of ports that connect to networks and other machines, etc. Here with these, would you qualify these as computers? I would. Okay, we got a smartphone there. You can actually use that as a communication device, but there's lots of other things in there. This is definitely a computer, very powerful computer compared to computers 20 years ago. And tablets. These are all computers. Other things that we have in our house could be computing. Yeah, I mean, if these devices have IP addresses, so this represents the idea of what we call the Internet of Things. If we've got a Wi-Fi network in this house, probably, and all of these devices can connect to it, and you've got security, and you've got all kinds of things for saving power. And each of those would have small computers in them. Everybody who drives a car, there's multiple computers in your car. So computers to get the gas and the air mixture perfect. Computers to control all kinds of the ABS systems. Your braking systems. That's computerized, and so you got computer sensors and computer processors that work with the brake system. All right, there's a lot of other little small devices that might work in what we'd call a personal area network. These, the watches. My watch, for example, it's not that smart a watch, but it's a Garmin watch. So it does GPS. So whenever I go for a walk, it'll record where I went. And then it Bluetooth connects to my phone. So it's measuring my heart rate as I'm. So that gives me an indication of my health. It measures my steps. These are all kind of just pretty basic things for a watch nowadays, kind of like everybody's got that, I suppose. But it'll also do things like I can set it to measure laps if I was doing some kind of competition. And then I could get my fastest time, etc. for whatever, so I could set up chords with it. And that's a pretty standard sort of thing that you find in very small devices nowadays. Now, a lot of these other things have computers in them. Apparently, I won't say that I'm familiar with all of those. Certainly, the smart bracelet, yeah, well, that's like my watch. Pretty much. Well, there's a smartwatch is separate, but you can have RFDs, radio frequency devices that you scan a frequency at them, and it sends back a message. That's how people's credit cards work when they do the tap thing. So you can have that on other things as well. So for example, they can put those RFIDs into clothing at the store, so that they can tell when somebody's taking the thing out, so they can be charged automatically. I think we talked about that last lesson with the somebody mentioned the Amazon store. You can go in there and you don't have to go to a cashier, because everything has its own IP address, and everything is communicating if it goes out the store, and that goes directly back to you, and you get to pay for it. So computers have input and output devices. So we see that there. I mean, some of us have Netflix or Redo special TV services, I suppose you could say, and those are computerized boxes that are sort of analyzing the signals that are coming over a fiber optic network and distributing them. Well, actually coming out of the router that's connected to the fiber optic network, because it's going to wherever you're connecting any two networks, you must have a router between them. But that's how that works. We got a smart TV at home. You guys probably do as well. So as long as you've got your Wi-Fi on at home, you can use all these apps, which give you all kinds of choices on what you're going to watch movies. So you can watch Netflix, you can watch YouTube just on your TV without plugging it into anything, because it's smart TV that has Wi-Fi in it. Are these things computers? Yeah, absolutely. They have computers in them. So this thing here, you look at that, that's actually a network. Each of those is a networking computer. And so they're going to be connected to networks and going to be managing the communications over those networks. I'm not sure what these other devices are, but yeah, what that is. But this is pretty obvious. It's pretty powerful photocopying and scanning machine. Yeah, so these ones here, I guess we're getting into the territory of supercomputers, types of things where that you would need if you wanted to know where every person in your country was at any one time. Who would want that? Yeah, all right. So, and if you want to do facial recognition on them and all that kind of stuff, and governments do that stuff. Computers have impacted all aspects of society, and there's a lot of reasons for it. They're very fast, they can store a lot of data, and they are accurate. That is, that they'll do the same calculation, get the same answer over and over again with, it's not going to change. So they're very good at that. Once you've got the algorithm in there coded, they do good. Computing is growing. The amount of data that's being stored, the processing that's happening. So, I mean, I don't need to go over that too much. I hope it's pretty obvious. When they first started doing computing, they were rare. They're only in banks and government places. Now everybody's got computers, lots and lots of stuff is being processed. And so I mean, we were talking about putting little computers in your clothes, right? So, I mean, it's getting to the point where we can just have so much data and so much processing going on. Supercomputers is that one that I was showing you there that's taken up a bit of a room. And so the idea of that, I mean, the first ones were used for sort of military and government, generally, because supercomputers can be kind of, so it's going to be typically for government and uses. And so tax offices in Australia was the first one to have a supercomputer in Australia, was a tax office. Yeah, also military. Okay, so we've got a bunch of slides that are following, which sort of come to which you're supposed to see the trend of, which is that in all of these places where we thought the computer couldn't do what a human could do, eventually they did, right? So eventually we got a computer that can beat the world's expert at computing, at chess, in a chess game. Eventually we got a computer that could beat the champions of Jeopardy, which is, general knowledge questions. That shouldn't be too hard for a computer. Chess is also very formulaic. What I mean by that is there's a limited number of moves that you can make. And so, yeah, that's kind of ideal for a computer, for a very powerful computer. And so, it can, so, I mean, the idea of winning chess, right, is to somehow calculate all the possible moves that you could make in your head and all the possible moves that your opponent could make in your head, and then come up with a winning strategy, right? So humans can do that, but seems like a good application for a computer. And like Jeopardy, yeah, so that's the idea to win that is that, that you have all this sort of random, sort of strange information because you've read a lot and you got like almost a photographic memory, or else, just because of the things that you've been exposed to. And because you got all that in your mind, when they ask these really weird questions, you come up with an answer. That seems like a good application for a computer. So, once you can store a huge amount of data in a computer, right? But there's some things that they haven't really been able to do so well. I'm not sure which is go on the computer. The 18 chap, I don't know what this is, AlphaGo, but I guess, okay. It's some game that they predicted it would be hard to win if, but a computer was able to actually do that. Yeah, okay, so as long as the game is formulaic, what I mean is it has rules that are not sort of arbitrary and not changing. Yeah, computers should be able to do something. Now we have this idea of artificial intelligence. The idea of that is that given a large enough amount of data, structured in the right way, your computer can actually make up the rules from the data. And so make up a rule from a test set of data and then apply that rule to other data. So that tries to imitate sort of human learning. So that's quite a good thing. Yeah, you're welcome. Sorry? I'm Mark Floden. This is INFS 1101. Yes. You're welcome. Yeah, everybody else is online. That's why there's nobody here. Well, it's online or the door's open, so you're welcome. So I should project this to the screen. So how could I do that? Excuse me, folks, I do have a person in class. In a minute, and you'll see what's on the screen. So the idea of artificial intelligence is that you can take, as I said, a huge amount of data, and that the computer can pull out trends out of the data that it would be, it'd just be too much for a human to process. And so from that, from the trends, it can determine rules, and then rules can be used to analyze other bits of data. That's my understanding of it. And yeah, so we're at that point now. Some of you might have seen the movie Terminator, and and so amongst the science fiction people, there's this talk of this concept of the they call it the what do they call that? When the computers become aware, right? And so when could it happen? It has to be the sort of the follow-on from our artificial intelligence, I suppose. Singularity is what they call it. I'm sorry, that's the word I was looking for. If we get to the singularity, then the huge amount of computer power that's available with machines, the science fiction people have been worried about that for a long time. There's a movie in called 2001: Space Odyssey. So that was back in the 1970s, 60s. And so they were thinking about it then, right? That, that the computer was talking to the guy in space, and the computer came to the conclusion that the people were really the problem. And so the computer went about sort of solving that problem. Yeah, I mean, if you're a computer, you might come to that conclusion. So that's a problem for people. I'll just leave that to the computers, not to the computer scientists, to the science fiction people. So that's the idea. If I was to summarize that lesson there, I would say that computers have been making huge strides over the last 80 years. We didn't have computers that did much before 80 years ago. According to our lesson yesterday, yeah, the computer history, if you started with the abacus, okay, it's been a couple of thousand years, but I mean, it's really got going, ramping up since we got integrated circuits. And so, so we're talking about really in the last 40 or 50 years. So in the last 40 or 50 years, we've had this sort of exponential growth in computing to get to the point where, yeah, we had Google cars trying to have an autonomous car, and they did have some glitches with that. No, I'm not saying that they won't get an autonomous car. I think they probably will. But it may take a little bit longer because the problem was a little bit harder than they thought it would be. So once they figure out, and the problem that they had with the autonomous cars was really in seeing. So seeing is not just looking out and seeing colors and images and things like that, but it's also the movement and the interactions between them. And the way that humans do it, the problem is that our scientists think they understand it, but there's still some little gray areas there of just what it is that we're doing when we're seeing. And it is a very important thing for any animal, including or human, who's very active in the world, who was ever a prey or a predator. Seeing is a very, very important part of what they do. And so in our brain, there's a very large section of our brain which is just dedicated to seeing. With some birds, there's even bigger relative to the rest of their brain. And so there is a lot of processing there. It doesn't sort of, it's not just like, well, we'll just put a few cameras on the car and, we'll pick up everything and that'll work. It's a little bit more than that. All right, so I'm going to stop recording there, and maybe there's some questions that you guys have.